Welcome, everybody. Thank you for joining. I'm going to say something in Spanish. Bienvenidos. Gracias por conectaros. So firstly, I want to advise that we will record the session. So you are going to see some information about that at the beginning. Today we have a joint webinar to talk about how to do intelligence analysis with visual exploitation. My name is Alejandra. I'm business developer manager at Future Space. You will hear also Anna and Isabel that are software designers in Future Space, and Jan, that is product manager at Cambridge Intelligence. So let me go to the content of the webinar. The webinar is structured in 4 parts. First, we will do a quick introduction about the 2 companies and why we are here together. Then we will do a demo of 2 user cases. And after that, we will cover some advanced visualization capabilities from Cambridge Intelligence. And we will close with questions and next steps. Please, during the webinar, feel free to drop questions in the chat at any time. You can do it in Spanish, in English, not in very complicated languages, but we will be very happy to answer all that questions. Also, I'm gonna launch now a quick poll that you will see on the right side. And it will be great if you could take a moment to answer them during the webinar. I guess that you can see it now. Great. So firstly, who is Future Space? Future Space is a Spanish technology company with 30 years of experience. Our work covers intelligence, artificial intelligence software, telecom, and IoT. And we operate internationally and have a strong experience in defense and security sector. We work with defense administrations and also law enforcement agencies in Spain and in other countries in Europe and South America. As well, we work for corporate sectors as defense industry that is close to government sometimes not, but all the key customers that we have maintain high levels of security, and this is why we maintain important certification related to security, to quality and resilience. And in Spain, we highlight the compliance with the Esquema Nacional de Seguridad in a high level. This is very important for us in order to give a proper service or product to our customers. Jan, please.
Yes. So yeah, just a very quick introduction from my side. So Cambridge Intelligence, we build toolkits for software developers to do front-end connected data visualizations. This is something we've been doing now for over 15 years. We started, first of all, in the network and graph visualization space, specifically for intelligence and security and policing use cases 15 years ago with our first kind of product key lines. And we've since then grown our portfolio, as you can see on the screen, to encompass 4 products to date, and they also now include geospatial and temporal or timeline visualizations as well. And our toolkits to date are used by hundreds of government and enterprise customers, as well as now a growing number of partners like Future Space across the world. We're in solutions that are deployed to SaaS cloud products, to on-premise deployments, as well as sort of highly sensitive, disconnected environments, because we are built from proprietary code and have almost no dependencies. And recently we've seen a growing interest in the use of our toolkits to create kind of combined, more powerful and more interactive sort of user experiences. And this is really the kind of the focus of the demonstrations and the content that you're going to see from all of us today. Back to you.
Great. So together, Future Space and Cambridge Intelligence, we deliver end-to-end intelligence analysis platforms tailored to law enforcement agencies. By the side, Cambridge Intelligence provide industry-leading visualization technologies for graph, geospatial, and temporal analysis with the tools that Jan mentioned. And with these tools, we can use them to uncover hidden relationships and patterns. And Future Space, by the side, complements this technology with deep system integration experience that we have in OSINT analytics, for example, or artificial intelligence developments, and also working directly with European law enforcement agencies that give us the experience to apply all that SDKs to a specific use for investigations, like the ones that we want to cover in the demo. So together we build these solutions that are operational, that helps law enforcement to align with legal and governance requirements. So why talk about data visualization in legal investigations? So here we are facing an exponential growth of information. The digitalization has multiplied the available data and the number of investigations that have increased because of the cyber attacks, fraud, and abuse. And also at the same time, the analysis that face the people that does these investigations face major difficulties as data overload that makes very hard to find what is relevant and what relationships are behind all that data. And also data silos and legacy IT system complicate even more this analysis. And this is why we propose to do data visualization in graphs, in maps and timelines, because it helps teams to analyze better all this amount of data and uncover these hidden relationship and anomalies. So in the practical law enforcement scenario or the daily work, the users can integrate and visualize data that comes from several sources and formats, and then turn that data into actionable intelligence to solve cases more efficiently. At Future experience with leading Cambridge Intelligence SDKs as Keylines, Chronograph, and MapWeave, that are the tools that we are using in the demo. And we have experience combining them effectively to design and develop platforms that are tailored to the specific operational needs that our customers need in those platforms. So now we will work through the two investigative scenarios that we have prepared. First, the one that is called Seguridad Operación Ruta Sur, that combine geolocated information and data stamp data from a drug traffic case. And secondly, we are going to an IP traffic analysis that is called Redes Topología Incidentes. All the data has been prepared in order to show the capabilities of these kind of platforms. So we can go straight to the demo on how visualization can work.
Okay, I'm gonna share my screen now. second. There we go. I believe you can all see it now. So, well, good afternoon, everyone. For the purpose of this use case, let's imagine we have gathered intercepted calls, vehicle tracking, money movements, port records, but we have received all that information fragmented from different sources and in different formats. Here we have what we have called Operación Ruta Sur, which is a drug trafficking operation from Morocco to Spain with 12 suspects and 4 shell companies over the course of 11 days. I'm going to show you how the 3 libraries, Keylines, Chronograph, and Mapwave, can turn that scattered information into a full story. Let me start by introducing each library separately so we can then understand the 3 of them working together to build the full narrative. Let's start with Keylines. Keylines is a network graph engine with entities as nodes and relationships as edges. There are 3 main things that I would like to highlight about it. First, centrality and pattern detection. Right now, without any interaction, you can already see that there's one node that has edges going into every compartment, and that's degree centrality made visible. Second, we have clustering and hierarchy. We could group by role, by risk level of the entity, or by risk level of the relations. The graph reorganizes, and what at first can seem like kind of a tangle then becomes readable and helps understand the chain command. And third, we have interactive filtering. For example, we could remove vehicles from the graph. We could decide to keep only people and phones, if that's what we need to see at the moment. We could maybe add companies back. And we could decide to see with these entities only the ones that have a high risk or a critical risk. Let me put everything back on. So, as we have already established, the graph places a single node on the center. We have Manuel Rivas. If we look closely, we see he appears connected to almost every compartment: logistics, route surveillance. There's no other node that has that reach. If we click on any node or on any relationship, we will find a panel with all the details we have had or we might have found about the entity in any other moment. The same thing applies to a relation. So leaving Keylines and moving on, our second library is going to be Chronograph. Here we have a timeline visualizer built for large volumes of events. Its 3 main capabilities would be, first of all, dynamic and temporal zoom. We can switch from a wide-sweep view, which is what we have now, to a minutes-wide view really easily. The events don't disappear, they just compress or expand, adapting to whatever you need to see at the moment. Second thing would be simultaneous event correlation. At any zoom level, you can see what's happening across different threads at the same time. Every row is an entity, and every point is an event. And third, we would have entity grouping and filtering. We can isolate one person or a vehicle or a phone and see only their events while everything else fails. For example, here, we could choose to see Manuel Rivas and his interactions with any other entities, or we could directly search for him and see only his events on the timeline. For our particular case, the timeline will give us an irrefutable sequence. If we focus here on March 12th, we see that within a 4-hour window, we had a container crossing the strait. We see someone appear, Omar Tazi, that will clock in Algeciras port, and a truck with the plate 4832 LMK leaving the port. So we can see that here. The journey through the strait We have here Omar Tazi that will appear on the docking in Algeciras, and we then see our truck with our cargo leaving the port. Those are three different events that we could have received from various data sources, and we can land them all in the same timeline. Moving on to map web. Here we have geospatial visualization. It works with coordinates, with routes, and in our case, with vehicle animation. As on the other two libraries, three main capabilities. We would have route visualization over real cartography. The relations we see here on the map are the same ones that we saw on the graph earlier. And the map also tells you the kind of relationship that is painted between every entity. We have, for example, red for hierarchy, yellow for transport, or lilac for communications. Second key capability would be vehicle animation with temporal playback. We are going to see this animation in the narrative later on, but the nodes that represent vehicles move along the map driven by GPS or AIS data as a reconstruction of whatever happened at that time of the operation. And the last thing would be location and event cross-referencing. If we click on any of the markers in the map, as well as in the graph, we see a panel with all the information that we have about that point in the map. The map is where the physical movement of the operation lives, and later on we're going to see the crossing, the port exit, and the convoy going north with the cargo. Each mark we do on the map generates an event on the timeline and node on the graph. Same thing happens with the three libraries. They all have an interconnection between them, and whatever we choose to see on one of them, it gets represented on the other two. Now, having seen all the libraries on their own, let's see how the whole operation unfolded. Okay. Let's start with the full network. As we have already established, 12 people, 4 companies, vehicles, and phones. As we saw earlier, there you go. As we saw earlier, the graph structure shows the most nodes clustered within their own compartments, but we have one node that has direct edges into every compartment while keeping its distance from the cargo. Here we have Manuel Rivas with the cargo far away from him. He ran the whole operation without actually ever touching the drugs. On March 10th, which is 2 days before the container arrives in Spain, the timeline shows Karim Ben Ali calling Manuel Rivas. Here we can see that. And that is when Algeciras gets chosen as the entry point for the operation. If we look at the map, we see that every actor in that decision has a physical presence around the port. We have Karim Ben Ali, Omar Tazi, and Importaciones Mediterráneo, which will be providing paperwork cover. If we check the graph, while Rivas is nowhere to be found in the map, he has a presence here because he's connected to everything by different phones and calls. Okay. If we now focus on the map, we see there's some kind of communication between Ceuta and Algeciras. On March 9th, the timeline shows, we can see here, how Fadel Ouali delivers false documentation in Ceuta. On the graph, we can see that structure represented with 2 companies with their own managers and Ceuta Sport. On March 12th, we have, one second, because of the delay on the app. We have the container leaving Tanger Med. The timeline marks both moments. Let me expand it here. The departure at 1:30 approximately, and the docking in Algeciras at approximately 4:30. On the next step, we can see that the cargo, we can see a yellow, we can see a yellow truck with plate 4832 LMK, which we mentioned earlier when we were seeing the timeline, leaving Sevilla. But in the graph, we can see there's a second truck referenced here, also leaving Sevilla, leaving the port for Sevilla. And that means there was a second truck doing almost the same route as the first one, but without, without the load. So, well, that would be a decoy. We see the cargo reaching Sevilla by mid-morning, and then a convoy of 2 vans leaves at 4:30 from there with the load. As the map is marking the journey, the timeline logs the sequence. We have here an encrypted message saying that the route was clear, a checkpoint warning at a place in Bailén, and then we have a technical stop in La Carolina, which is a service area. Finally, both trucks arrive at Madrid. At this point in the graph, we are once again seeing the full network with distinct clusters, a supply chain at the top, logistics on the left, and finances at the bottom. We can see there's no direct connection between them. Everything runs through Manuel Rivas, which once again is at the center, through his prepaid phones. If we keep moving, the graph shows 3 delivery points, Madrid, Vallecas, and Getafe, and the people running each one of them. And the timeline logs both arrivals at 9 p.m. and 10 p.m. We also see distribution in Getafe the following morning, and we know there's a collection of money straight after. Near the end of the operation, we find some new people. We have Marcos Torres delivering cash to someone called Elena Vidal. Another third person, Lucia Vega, that converts the money through one of the companies, Inmobiliaria Castilla, and the timeline logs 2 rounds of laundering at this point. One there, and a second one, one here. And at the end, there we have the whole operation. 11 days that took the full operation to complete, with every entity represented on a row and every event time-stamped with a point. The peak we had was on March 12th, as the vessel crossed and left the port. Then activity through March 13th and 14th, which is when the Madrid distribution of the drug happens, and the least labeled round of laundering in March 20, that marks the end of the operation. And that was it. The graph gave us the structure, the map gave us the movement, and the timeline, the sequence. And none of them on their own would have shown us the full story. And I leave you with my colleague Anna, that's going to show you same 3 libraries, but on a different context.
Okay. I'm sharing. Okay. Good afternoon, everyone. Over the next few minutes, we'll show how the internet grew from a single connection in 1991 into a global network, and how in 2020, one company managed to redirect traffic in its own benefit. The key idea is simple. The internet is not a cloud. It's a network of companies and organizations that agree to share traffic with each other. When everything works as expected, data goes to the right place. But if one actor behaves incorrect, traffic can be redirected somewhere it shouldn't go. What will you see is how to clearly kind of situation when it happens, when where it happens and why it matters. To do that, we use the three Cambridge libraries: keylines to understand who is connected to whom, a chronograph to see when this happens, and mapway to understand where everything is located. Seeing all the three together makes complex situation easy to understand and can explain. Let's go to the chronograph. The chronograph, this view answers a simple question: when did things happen and in what order? Each line represents a company operating a part of internet, providers, international carriers, etc. As the network grows, more companies appear, and eventually there are so many that individual entities became visual, hidden in the timeline. Times moves from the left to the right, as we can see. And what makes this view powerful is that it lets you instantly see how the network evolves over the time and quickly spot anything unusual. Now, let's look, for example, in 1991. There is almost nothing there, just one company that reflects the reality. At that time, the internet was still very small, but if we move forward to 1997, 6, 7, more or less, suddenly everything changed. Many new companies appearing in a very short time. This is the moment when the internet became a business. So you don't need to look of any numbers or different companies. The seed is immediately visible with the chronographs. And now let's go to the 2020. And on these points, we can see that the datasets become much denser, making it harder to isolate individual companies directly in the timeline. So we can filter, for example, Poseidon Energy. As we can see, the connection between Poseidon and others companies here. We can see that it started in July on 2020. But if we examine the history, there is nothing before the alert. This is the alert that we have with InfoState. So that lack of history is universal. It doesn't just show activity. It helps you focus and uncover what's missing, every incomplete data sets, like that one. In this case, that absence is a strong warning thing. And now let's go to the key lines, the graph. This view answers a different question: who is connected to whom and how. You can see the connection, the relationship between the companies, where each circle represents a company or organization to operate with another one in internet. The lines show how they are connected, and the number gives you an idea of the size of each organization, how much internet infrastructure they manage. Now, in this case, if we expand the node, we can see all the LANs and all the devices into the LANs. But let's go to the alerts. If I take an alert, can I see only the node that have the alert and the connection? At the first glance, it looks like a normal connection, but behavior behind is not. And this is where the value of the graph comes. It helps you quickly spot what looks normal but isn't. The graph doesn't replace the investigation. It helps to focus to the right place, and see in few seconds, understand how the company is connected, explore the internal structure, and identify exactly where something unusual is happening. For example, in this case, the alert. Now, the last library is the mapway. Here we can see all the dataset. We have a lot of data here, more or less, the most of the data. This view answers a different question, where things are and why that matters. Each point of the the map represents a company, place in a country, and the lines show who is directly connected with the home. You can instantly see the network in spread across the world. For example, in Europe, it's a highly connected. We can see Spain, France, UK, Netherlands, and there are many possible paths between them. And if one path fails, traffic can take other route. But for example, if we go to Poseidon Energy, that is the company that is seen in the last one that have alerts, we see that only has two connections. It's not about how big is a company, it's how many connections has, sino where it is. And this is the key value of the map. It reveals a strategic position that are not obvious in the views. For example, that one, we can see all the connections that could be have alerts. And now let's see what happens when we bring everything together. We go through the history step by step, like in the other kinds of views, and we can see what happened, where, and how it connects. If we go to start, this is the beginning of the all. Every network starts small and move forward in time. More companies appear and start connected. For example, here we can see here. Then a new wave arrives, digital device, mobile phone, and other platforms that grew up the network. And finally, companies expand globally, bring service close to users. In the last step of the timeline, we will see something change. A company triggers an alert, and the traffic doesn't follow normal paths. So what have we seen here with key lines? View helps to understand how things are connected, map with where things happen and where location matters, and chronometer helps us to understand when events happen and in what order. Depending on your needs, you can focus one of them or combine it, like in this view. What really matters in this outcome? You can spot unusual behavior faster, you can understand situation more clearly, and you can explain complex information in a way to others can quickly follow. It helps you turn complex data into a clear slide. And that's the value of Cambridge Intelligence. Now I'll hand over to Jan from Cambridge Intelligence. So I finish.
Thank you, Anna. Hopefully my audio is coming through. I'll just share my screen very quickly. Here we go. Yep. While that's coming, just big thanks to Anna and Isabel for the fantastic demos. I couldn't have done it better myself in terms of showcasing how the three visualizations kind of can come together and the interactivity across them for those two use cases. For the rest of the sort of demonstrations, I'm was planning to focus on just a couple of more kind of deep dive use cases that are sort of in our experience quite relevant to the intelligence and sort of policing kind of space. So the first is going to be a showcase looking at kind of high performance, so sort of visualizations on very large data sets, specifically looking at kind of pattern of life and the analysis thereof. And then the other is going to kind of take a very different tack and look instead at how you can sort of how Future Space and our partners can kind of build applications for you which focus very strongly on kind of user experience, maybe kind of messaging to very high level stakeholders, where kind of that simplicity and really kind of drawing out the kind of the key messages is really important. And as we mentioned at the start, please don't hesitate to ask any questions throughout. Just pop them in the chat, and we'll either answer them there in the chat or we can pick them up. We should have plenty of time at the end to kind of answer your questions as well. So I'll just switch to the first demonstration. Hopefully you can still see my screen. So let's open up the pattern of life demonstration. By the way, this is what I'm sharing here is our sort of website pages where you can kind of explore our various visualizations, and we sort of share the various showcases that kind of showcase how the visualizations can be leveraged to build various solutions. So here we have our chronograph product on the left hand side. This is our sort of timeline, our temporal package, and underneath and to the right hand side we have MapWeave. And you might have noticed there was a sort of a spinner as I was kind of opening this, and this is because we've here in this instance we have loaded in 1 million observations. This is using the very sort of famous Porto taxis data set. It's an open source data set that tracked the movement of I think about 400 taxis around Porto for an entire year. Here we are just looking at 2 months of data for the sort of the busiest 20 or so taxis within the data set. The way I like to demonstrate this is to kind of talk through it like how I would approach it as an analyst, sort of being asked to kind of, detect things in this data set. And there's typically kind of 3 main ways in which I might come about this. So the first is I might already know, like in Isabel's kind of demonstration, I might already know the entities that I'm interested in, and I just want to surface them within this data set and kind of follow them around, see who they are interacting with. So chronograph gives us, out of the box, these very, very sort of handy controls, like focus, which just lets us kind of focus on a specific entity or the connections, that they are interacting with. In this case, these are just taxis. They're not really interacting with each other, so I only see one at a time. But then we also have the pin controls, which, in this case, kind of allows us to sort of select, oh, I want to sort of foreground these particular taxis. And you notice that as we're doing that, as we're kind of changing the timeline range, we're updating what we're seeing on the map at the same time. And then you might notice as well is when this line here intersects, these various taxi journeys, we get the little, what we call a tracker node for that taxi on the map. And you can kind of interact with those as well. And you notice time is changing when I move them around. So these are things that, the visualization can just do automatically for you. And that's how Isabel was kind of able to kind of animate, the movement of the trucks and so on across southern Spain. So that's if I know who I'm looking for. What if I don't know who I'm looking for, but instead I have specific areas of interest, right? So let's take a look at the airport here. Maybe we know that, that there was some interesting activity. Maybe somebody flew in early hours, one morning, and we want to see, like which taxis kind of might have picked them up. So we can use, kind of, we can build, or Future Space can build kind of, experiences for you, which lets you sort of, filter, spatially, but also temporally, right? So I can sort of create a, spatio-temporal filter, which I can clearly see on the map. And now I'm only seeing the taxis which were observed within that space at that particular time. And then maybe I want to know, okay, of those 3 taxis, were any of them the following evening, dropping somebody off down at the main train station, right? So create another filter over here. Yeah, okay, taxi 263 was spotted in both places at those particular times, right? So that's if I have very specific areas of interest. But what if I don't know who I'm looking for, and my AOI, my area of interest, is really large? It's the entire city, right? Like, where do I start? So this is where the chronograph time, the timeline, and the heat map, the aggregated kind of view of all these events, becomes really useful. And that's why it's really useful to be able to handle very large data sets in the user interface performantly, because I can see across these million of observations and the corresponding over 30,000 taxi journeys. I can straight away see taxi 364 probably took a holiday here for 2 weeks, right? Or maybe it was being serviced. Another big gap over here, another one over here. But what I can also do with chronograph is I can do what we call scale wrapping. And so I can look at the exact same observations and the same taxi journeys, but I can see them wrapped around a repeating unit of time. So now, instead of seeing a linear 2 months, I can see the same events wrapped around the days of the week. And this gives me a very different perspective on the pattern of life. And here I can see, okay, there's something interesting going on with taxi 304. They're the only one who doesn't normally work in the sort of the latter parts of the day on a Sunday. But if I zoom in, I can actually see that they had one journey, one time on a Sunday, which they otherwise they don't do. So for me as an analyst, that is an outlier, right? It's something that I can latch onto. I can now switch off scale wrapping. I can go back to sort of normal linear time, and I can start to look at 3 or 4 in the context of the wider data set. Where else have they traveled? Have they been convoying with some other taxis? Where, what other areas are they visiting, etc. So that's pattern of life analysis in a nutshell. And again, please sort of share your questions in the chat. I'll swiftly move on in the interest of time to something completely different. So here, instead of using chronograph and MapWeave, we are looking at our graph visualization. In this particular case, it's key lines, but regraph for React development does exactly the same thing. And then we have the geospatial visualization over on the left-hand side. Here, we're using standard NATO military symbology to style our nodes. This is a requirement for a lot of our defense and government customers, and the libraries support integration with these kind of symbols. So we're looking at a artillery supply chain showcase in this case. And again, this data is based on an open source report from the Royal United Services Institute, RUSI, which investigated, and kind of published how, some of the criticalities in the supply chain of the main artillery pieces being produced by Russia. And here I've got this little breadcrumb along the top, which I use to kind of tell a story, of this supply chain. And I'm kind of unpacking the various levels of the supply chain with each step. So we started with the artillery pieces themselves. Then we've got the assembly plants, like Ural Transmash here, sort of the hub where all these pieces are being assembled. Then we've got the component manufacturers supplying those assembly plants. Here we have an example of an annotation. So our visualizations can sort of, they all come with sort of various instances of ways to call out information for the user. These can be created by users, but it can also be, created maybe by algorithms or something kind of drawing your attention, popping up call out. So here I'm literally just telling you, you can hover on these links, and I'm going to show you exactly where that route is, on the map and the sort of the locations involved there. And you can also use annotations effectively like the combos that you saw in Isabel and Anna's sort of examples, to kind of group and cluster nodes together, show these are all the chromite importers in Russia that are sort of importing chromium from around the world and then supplying it to the Russian MOD. So we'll sort of take it to the last step. So now we're looking at also these various chromite suppliers. Why is chromite interesting? It's used as a coating material for the inside of the artillery barrels to kind of, sort of for them to kind of resist the high temperature and pressure application when artillery guns are firing. And they're being sourced from various places around the world. And then we can use, styling and the overrides of this styling to kind of focus the user's attention to specific parts of the supply chain, if we want to do that. So here we're focusing on just the parts of the supply chain that involves, suppliers from South Africa. And then, there was, I think Isabel mentioned kind of graph centrality. So this is a key piece of our offering. You don't have to be an expert in sort of graph analytics and graph centrality. I'm definitely not, right? But I can use the built-in package sort of algorithms to drive certain experiences and interactions. So here I'm automatically using degree centrality, which is one of the most common ways to kind of analyze supply chain networks. Like, which are the most important nodes? If I remove this node, how much of an impact is that going to have on the supply chain network as a whole? And we're able to run the betweenness centrality on the sort of the schematic chart, but we can do the same on the map as well. And the reason why this is interesting to kind of have side by side is that they don't necessarily show the same picture. So, betweenness centrality on the right shows us that Ural transmesh is the most important, which we would expect. It's the one that produces, most of the self-propelled artillery pieces, and it's the one that kind of receives most of the components, and so on. So it's the most important in this network. And indeed, here on the left, Yekaterinburg comes up the biggest because that's where Ural transmesh is based. However, Novorossiysk, for example, shows up as quite important too. Yet, if I overlay the military symbols here, which represent all of these nodes on the map, none of them are actually based in Novorossiysk. So why is it, really critical to the supply chain? Well, it's because it happens to be the route, sort of on the route through which, nearly half of these, chromite suppliers kind of ship their chromite into Russia, right? So it is still a very important node, which wouldn't feature on a kind of high level, sort of strategic level supply chain view of this at all. But at the tactical level, the exact routes through which these vessels, these trains or these trucks kind of might be shipping these things, it really matters. That's everything I had to kind of share with you for today. So I'll just kind of switch back to the presentation and just share my screen again and hand back over to Alejandro.
Thank you, Jan, for these advanced capabilities. This is very interesting. So before the close, we will be happy if you have any other questions. We can answer here. And at the same time, we launched the final pool. We really appreciate if you could take a moment to answer it. Meanwhile, we answer the questions.
Yeah, I'm just looking through
the chat. Yeah.
So as always, we've got quite a few questions about data and the sources of data, which I think, Alejandro, you've been answering as you go. But yeah, for our demonstrations, we either use open source if they're available, or we synthesize data, which our AI friends make very easy these days. But of course, Alejandra and the team at Future Space, can kind of provide you with data sources as part of the solutions that they kind of develop for you. We at Cambridge Intelligence ourselves don't provide data. We just build the front end tools, which enable Future Space to build the solutions for you. But yeah, we do support and have kind of examples on our website, a very wide array of different data formats that are kind of, can be supplied to these visualizations, and that's absolutely something that the Future Space team can kind of help you with.
Yes. In fact, if there is any specific use case that you need help, maybe because of the data, or because you have questions about how the format can imply the visualization of that information, you can write us, and we are very happy to do a case study or maybe a demo, if it is available, about this kind of capabilities that you will need.
In case anyone hasn't seen it, I don't know if the polls kind of pop up for you, but that you should see a little poll kind of icon on the bottom right of your screen, and hopefully with a little alert to show you there have been some polls launched. So if you do have a minute, we would love your input on those two questions. Let's see, is there anything
Another
else?
thing that John mentioned at the beginning of the presentation was about the on-premise option. This is another thing that we do. It's very common that some data is confidential, or maybe have sensitive data. So we also deployed on-site solutions that maybe have to be with no access and have to be deployed in secure environments. So this is very common also for this kind of projects. Also, the integration with different customer databases. This also is very common, that maybe the customer have some information in a MongoDB database, or maybe in an unstructured database. So we do that kind of project where the information comes from different systems.
Yeah, I think that's a really good point, Alejandro. I think it's speaking specifically for the visualizations. There's no call home kind of capability. They're all built kind of in a proprietary way by us at Cambridge Intelligence. The graph visualizations that you've seen and the chronograph, the timeline, they have zero dependencies. So there's no open source libraries. You're not pulling in any sort of cyber security vulnerabilities or anything like that. And that's one of the many reasons why a lot of government and defense and intelligence customers kind of use our visualizations for that reason. The MapWeave, the part, it has one dependency, and that's DecGL, which is like the way you do performant GPU enabled rendering in a browser for maps these days. So that's one dependency there. But you would likely see that across all of the providers of these kind of visualizations. Well, I'm not seeing any more questions. There is still time, folks, if anybody's got anything to ask.
Andrew's tipping.
What is the limit of the data amount? Yeah, that's a really good question. So I can sort of speak specifically for the visualizations themselves, and then maybe Alejandro, you can kind of speak to kind of the solutions you've kind of deployed and the scale of that. But specifically within the visualizations, the graph visualizations, they're capable of visualizing tens of thousands of nodes and links. Now, it's not something we normally recommend in terms of the user experience. It's often better to show the user where you want them to focus, and then we have a whole array of features that can be used to expand the network, to kind of take your investigations down different paths. But that's the sort of on that side. And chronograph and MapWeave, in terms of the number of events and the corresponding number of like observations on the map, as you've seen, it's the order of like 1 million. And at that point, you're reaching the limit of what your browser like memory will handle. Now, obviously, and this is where I kind of can hand over to Alejandra, but when solutions are actually built with a server backend and everything, you can. I mean, we have customers who use our visualizations to visualize billions of events, right? It's that's where you kind of get to how do you serve this up to the front end. And I don't know if you wanted to add more there, Alejandra.
No, I mean the limit is more about the visualization that will the limit of the purpose, but.
We feed data from distributed data storages for a particular area of interest. What data structures do you recommend? I can't speak for the back end. The front end has a very sort of simple JSON format which it receives. So how you decide to serve that from where is really up to the kind of the application development. I don't know, Alejandra, if you.
Well, it depends on the case. We have been working with MongoDB databases, also databases from Oracle. It depends more of the kind of data that you need to visualize. In this case, for the demo, we have been data that comes from I think it's MongoDB also, or maybe we have done something with the JSONs, no, Isabel?
Our visualizations come directly from a JSON, but just for our own sake and not having to transform the data in any kind of way, but we could do the development that requires the case you need. Yeah, there's no problem on that.
Nice. Well, I think you're very welcome.
Yeah. In any case, if you have any other questions, or you can arrange some meeting to talk about any specific case, you can write us. Here you have my email, but also you can contact us, and we will be very happy to answer your needs or talk more deeply with your needs.
I think we're coming up to time, so we'll probably start to wrap up. But yeah, thank you everyone for attending. Hope you found it interesting and useful. And yeah, as Alejandra said, please don't hesitate to reach out if you'd like more sort of bespoke demonstrations.
Yeah. Okay, thank you. Have a nice day.
Thank you. Bye-bye.
Thank you.